Welcome everyone to a very quick overview of what lesson 1.1 is from calculus, which is called change can occur at an instant. What I'm here to do is give you a very brief overview of what's being talked about and the two major things that you need to know is what a secant line is and what a tangent line is, also known as how do we find average rate of change and how do we find instantaneous rate of change. Average rate of change is actually something that you're really familiar with, at least hopefully, right? So if I look at this part of the Desmos file, if I look at this f of b minus f of a over b minus a, that is slope. That is slope of a line. That is exactly how you found it before. y2 minus y1 over x2 minus x1, rise over run, vertical distance over horizontal distance. You've messed with that a lot. You've done that a lot. So this is what we call average rate of change. And if I were to draw a line, you can see here that I'm picking a random x value, and I'm going to plug it into the function and get a random y value that is assigned to it, right? And I have these a's and b's here that I'm going to get a line, and that line is going to touch the graph at least twice. It's going to hit it at the a point, a comma f of a, which would be this 2.7, which is right here. So that's a comma f of a, and then also at this point here, b comma f of b. So it hits it twice. Nothing really special about it. I can change the a value, I can change the b value, and it tells me the rate of change, the average rate of change between the 2 points in the graph. This point here and this point here, there's not much growth over a lot of horizontal distance, but if I change it a little bit, there's a lot of growth over less horizontal distance. You can see that kind of there. We call this black line here a secant line. Sounds familiar? Same term, spelled the same way from when you learned trig. Well, if there's a secant line, well, let's do another trig name and let's call something a tangent line. So look at this line here. Look at the difference between it. I can move it around too. You'll see that it only touches the graph once. It like hugs that side of the graph. And it really does only intersect the graph at one specific point. That is the instantaneous rate of change. If you see here, we got this f prime where the slope is. I will teach you in Unit 2 how to find that. But for now, we can approximate it by having, if I turn on all of these things, if I take this b value and I make it really, really, really close to the a value. The closer I get, the closer those lines get. Now you'll notice that the black line does go away when they're the same. That's because you divide by 0. We'll talk about how to fix that later, but for now, if I get this really, 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 really close, so like 1.79999, it doesn't really like that, but if I get this, they get really, really close. So that is essentially what 1.1 is. It's instantaneous versus average rates of change.